Hello, I am Pascal Kazadi, and today I will be talking to you about dark matter. Now, before we get into it, I'd say it's safe to say that dark matter is a decently complicated topic, so I think that there's some background information that's important to know before we get into this. Now, in 1933, Swiss astronomer Fritz Zwicky was studying the Coma Cluster, which is a collection of more than 1,000 galaxies. These galaxies are gravitationally bound together, so they all orbit around their collective center of mass. Zwicky measured the orbital speeds of these galaxies and found that some were moving much faster than he expected. It was almost like if there was more mass in the galaxy that he could not see. Pulling everything inwards, so he proposed the existence of invisible matter, which he called Dunkel Materie, which is the origin of the term dark matter. And we'll go. Now, if you take a look at the graph here, we'll see that everything that we've observed in the universe up until today only accounts for about 5% of the composition of our universe. And if that isn't mind-blowing enough, scientists think that there's about 5 times more dark matter than there is ordinary matter in the universe. So that number is anywhere from 25 to 27%. And scientists also think that the remaining 68% of the composition of our universe is made out of dark energy, which is a whole other topic on its own. But personally, I think that more research needs to be done on this remaining 68% before scientists can confidently say that the remaining 68% of the universe is made out of just dark matter. And at first, astronomers thought that dark matter might be hidden in objects that appear dark because they emit no light, like black holes, or that are too faint to be observed from large distances, like white dwarfs. However, these objects would be made out of ordinary matter, and as scientists have discovered, only 5% of the critical density consists of ordinary matter. Although no one has found dark matter yet, scientists are almost certain of the existence of dark matter within the universe. Scientists realized this after researching the density fluctuations of the universe. They realized there wouldn't have been enough mass to create the galaxies as soon as they did after the Big Bang without the presence of dark matter. Along with this, scientists realized that in the early hot stages of the universe, the gravity was not strong enough to cause the galaxies to form without the presence of dark matter. And if we just take a look at this picture here, this is kind of a timeline of the universe, and basically what it's saying is without the presence of dark matter, the galaxies would not have formed when they did, and obviously they did, so scientists were able to assume that dark matter was there. Now getting more into what dark matter actually is, like I mentioned before, it is still widely unknown, but it takes up about 25% of the universe. It does not interact with light at all. It does not emit or absorb light, but yet it does interact with gravity, which is why we are able to make the assumption that it is there. And actually, there is more known about what dark matter isn't than what it actually is. Scientists have discovered dark matter is an antimatter because antimatter produces special gamma rays when it interacts with normal matter. And this is just a funny picture that I found that kind of represents how little we know about dark matter. I thought it was funny. It says, "We're quite confident that it smells like cinnamon." Now, how they detect it. Scientists have been trying to detect dark matter for some time now, and have conducted a lot of experiments that have been unsuccessful, except for one. There's a dark matter detector under the Swiss Alps by the name of Dama Libra. They have been collecting data there for 20 years now, and every year they get the same interesting results. The dark matter detector peaks in June and is in the lowest in November. Scientists think that this could be the first real evidence linked to dark matter. The theory behind this basically is the idea that we're moving through space faster in the month of June because the Earth is orbiting around the sun in the same direction that the sun is rotating within the galaxy. So therefore, we're traveling faster through space and dark matter in June, and we're moving through dark matter the slowest in November when we're orbiting the opposite direction that the sun is rotating through space. And this actually is the Dana Libra chart, and as you can see, every year it's the lowest in November and peaks in June, and it's like that every year. Although scientists have possibly made a discovery with the data from Dana Libra, as I mentioned, detecting dark matter is extremely difficult, and the results from their data could be direct correlations to dark matter, or they could be completely off. And this could be because of a number of other reasons. The actual process of detecting dark matter has to be done deep within a mountainside cave, and so they can block out as much outside interference as possible. And the detectors have to be designed to shield from any radioactivity or neutrons that are trying to pass through the detector. Along with the detectors have to be cooled to almost absolute zero so the scientists can measure the small temperature changes in the particles. All of this and the probability of a particle colliding with the nucleus of an atom inside of the detector is only 1 in 1,000. And I thought that was crazy. And these are some pictures from inside of Dana Libra while they're conducting the experiments. I'm not quite sure what they're doing in this picture, but I thought it was pretty interesting. Like I've said, dark matter is still widely unknown, and further research and information on dark matter could lead to an infinite number of possibilities. Everything that we know about Earth and the universe could just be the tip of the cosmic iceberg of what the universe actually is capable of, and along with the other countless possible elements, minerals, and resources it has available. There has been research that shows that there could be possible whole elemental tables that we have yet to discover. If scientists continue to study dark matter, and hopefully one day we can solve the mystery that is dark matter. Thank you, folks. That is all, and here are my references.